This video looks into construction and programming of my WRO2023 90-second robot. First, I will look in detail at the robot construction. Then I will explain how the most important My blocks are set up. Finally, I will have a look at the overall program strategy. We'll start with the construction. The underside view shows some important details. There are two light sensors, one at the back and one at the front. This makes it possible to line follow in both directions, which helps to make a faster strategy. You can see the boat grabber at the front and a light sensor at the side to read the color of the marker blocks. Each side has two wheels. I thought this would help with accelerating, but perhaps it's not so good for turning. One day I will look into this. The top view shows the boat grabber from above and the container grabber at the back of the robot. The side view shows the color sensor. This is for reading the colors of the two marker blocks while fueling the ship. There is a line follower sensor at the front under the boat grabber and at the back under the container grabber. At the back you can see the adjustable mounting for the rear caster. This is adjusted so that the driving wheels are always in contact with the table base. Here is the motor which we have to use for both grabbers. This is possible as we do not have to lift containers at the same time that we move the boats. Now onto the boat grabber. This needs to be quite robust, as it has to turn with the boats, move quickly, and then release the boats cleanly in the right positions. Here we see the motor drive to the grabber from the top and from the front. Finally, we come to the container grabber. This has to pick up the white and green smaller containers and the larger blue ones. It then has to travel with the container and place it cleanly onto the boat. Here we see the motor drive to the container grabber in more detail. That completes our look at the hardware. Now we'll move on to the software. I will start by examining the main My blocks used to move the robot around. First, a very simple My block which moves for a distance. The parameter MP sets the speed in percent, a positive value for forwards, negative for reverse. The parameter distance sets the number of centimeters to travel. Now we will look at a My block which changes the speed from MP1 to MP2 in the number of seconds given in parameter time. The robot can drive around more accurately with acceleration and deceleration. First, we reset the timer to 0, so we stay in the repeat until loop for the number of seconds given by the parameter time. Inside the repeat until loop, we calculate the value for the speed MP based on the timer. When the timer is at 0, MP equals MP1. When the timer reaches the value set in the parameter time, MP equals MP2. In between, the speed is proportional to the time. To make the robot slow down, set MP1 to a higher value than MP2. This block will also ramp from speed MP1 to MP2, but it will stop moving when the robot gets to a black line. The speed ramping uses the timer in the same way as the previous block. As the robot can drive forwards or in reverse up to a black line, we have to select which of the two light sensors we use. If MP1 is negative, the robot drives in reverse and we set the variable sensor to D. Otherwise, we set sensor to C. We then remain in the repeat until loop till the selected sensor is on black. Inside the loop, we calculate the speed ramp as before. If the time for the ramp has been reached, but the sensor has not seen a black line, the speed is maintained at MP2. When a black line is seen and we drop out of the repeat until loop, we then drive for a further 7 centimeters. This will center the robot on the line as the sensor is 7 centimeters from the wheel axis. The next block we will look at drives in a straight line for a defined distance. The speed is ramped from MP1 to MP2 as for the previous blocks. The parameter distance sets the number of centimeters to travel. We first set the relative position of motor A to 0. This causes the motor to stop momentarily, so it is not a good idea to use this block when already moving. I later found a better way of doing this, which I will detail in another video. We next calculate how many degrees we have to rotate to move the distance in centimeters required. We remain in the repeat until loop till we have traveled the distance specified. The speed MP is calculated in a similar way to the previous blocks, but based on distance traveled instead of time. The next My block ramps the speed from MP1 to MP2 in the time specified, but also is a line follower. After resetting the timer, we have to decide which sensor we will use. If the speed MP1 is negative, we travel backwards using sensor D, and for forward motion, sensor C. Inside the repeat until loop, we calculate the speed MP exactly as for the My block drive ramp time. We then have a proportional line follower. First, the reflected light value of the selected sensor is subtracted from the variable solver het. This is halfway between the reflected light value for the sensor on black and on white. The value is usually around 60% and is set up at the start of the program. Then we multiply this error signal by the variable kp, which is also set at the start of the program. kp is adjusted to give stable operation of the line follower. I will add a link at the end to explain how to do this. The resulting control signal is then added to the speed of one motor and subtracted from the other so that the robot follows the middle of the black line. The next block combines ramping for a time with line following and driving up to a black line. We have already looked at these functions separately, so I will not discuss them again in detail. The same goes for this block, which combines ramping for a defined distance with line following. Finally, we come to the spin turn my block. This is a very simple way to turn, and it is used for all the turns the robot makes. The parameter MP sets the speed of the turn. A positive value gives clockwise rotation, negative gives anti-clockwise. The parameter angle sets the number of degrees to turn. First, we set the movement speed to the value of MP. Then we calculate how many wheel degrees we need to turn the robot by the degrees set in parameter angle. To do this, we multiply by the ratio of the distance between the wheels to the diameter of the wheels. We then use a move left or move right block depending on the direction of rotation. The program is organized in 3 levels. This gives a good overview and makes it easy to locate each action if something has to be changed. In the top level, we have a small number of my blocks which carry out the main tasks. The attached comment gives the program name and dates details. The init my block sets up everything we need at the start of the program, such as where the movement motors are connected and the values of some variables. The remaining my blocks carry out the basic tasks required. The second program level contains the main functions to be carried out, such as move ship 1 or get ship 2. Each function consists of a sequence of my blocks from the lowest program level. In the lowest program level, we have the my blocks that we have already looked at in detail. This 3-level program structure makes it easy to pinpoint problems and make improvements where necessary. I hope you found this video interesting. Here is a link to a video which explains how to optimize your line follower, and here is a link to the robot which completes WRO2023 Senior in 68 seconds.